All right, my darlings, your favorite word problems. Okay, so because I couldn't be in class today, I'm doing a video of these notes. You definitely want to listen and follow along and maybe stop, rewind, pause, whatever you need to do to help you understand how to come up with your linear equations and inequalities for word problems. So we're going to start with equations today. Systems of equations in word problems. So mystery numbers. It's telling us that the difference of two numbers is 34. And let's stop right there. The difference of two numbers is 34. We know that is means equals. Difference, we know that means to subtract. So our first part of the statement is already telling us that the difference of two numbers is going to be 34. Let's identify or give name to these two numbers. We're going to let x equal the first number. We'll let y equal the second number. So the difference between these two numbers is going to be x minus y. The difference of two numbers is means equals 34. Now their sum is the 338. Their sum means to add, and remember is means equals. So if we add these two numbers, we get 338. Now we have a system. With this system, we can choose to use substitution method or elimination method. I wouldn't graph it. Nobody wants to graph these large numbers. So in this case, because it is set up for us such that our y's cancel, I'm going to go ahead and use the elimination method. Remember, when you eliminate, you are adding your second equation going down. So x plus x is 2x. Negative y plus y is 0. And then this is going to give us 372, 4 plus 8, 3 plus 3, plus that 1 you carried, and then bring down your 3. Now divide both sides by 2, and x is equal to 186. That gives us the first number. Great, but we need to find the second number. So take this value, plug it into one of your equations. I'm going to choose the top equation. If you want to choose the bottom equation, that's fine, but I'm choosing the top one. 186 minus y is equal to 34. Folks, I chose the top one because I'm working with smaller numbers. If I subtract 186 from both sides, I get negative y is equal to negative 152. Use a calculator if you have to. Never leave your y as a negative, so simply multiply both sides by a negative 1, and you get your solution. Y is equal to a positive 152. So yes, of course, we could write this in coordinate form. Our x value is 186. Our y value is 152. Let's take a look at the next one. Take it one sentence at a time. One number is 17 more than 3 times another number, and then the sum of those two numbers is 41. We need to find those numbers. Once again, let's take it one sentence at a time. So one number is going to be 17 more than 3 times another number. Well, I'm going to again use x, and I'm going to use y. So if one number is going to let y equals one number is 17 more than, so I'm adding 17 more than 3 times another number, that another number I shall call x. So that's going to be 3 times x plus 17. My second statement, the sum of the two numbers is 41. So my other statement is going to be that the sum of those two numbers, x plus y, is 41. Okay, so we have a system here, folks. We have a system. I'm going to use the substitution method. I chose the substitution method because it is already telling me what y is. Y is equal to 3x plus 17, so I'm going to plug it into my bottom equation for y and solve for x. X plus 3x plus 17 is equal to 41. Solve for x, subtract 17 from both sides. 1x plus 3x is 4x. And you get 24. 41 minus 17 is 24. X is equal to 6. Great. X is equal to 6. I'm going to go ahead and take that value and plug it into my equation here to solve for y. Y is equal to 3 times x, which is 6, plus 17. Folks, that's 18 plus 17. So that means y is equal to 35. So again, I'm going to write 6, 35. I'm writing it as xy coordinates. Next section, people have money. People have money. So now we're going to focus on money questions. So Natalie has $84 more than Sierra. And together they have $458. How much money do they each have? Well, we don't know what Sierra has. We don't know what what Natalie has, except that she has got 84 more than Sierra. And we know that together they have $458. So let's go ahead and say Natalie is X. And we're going to say that Sierra is Y. You can use N and C if you like. But I'm going to use X and Y. So X is equal to Y plus 84. X, which is Natalie, she has 84 more dollars than Sierra, and Sierra is Y. So there's one equation. My second equation is going to come from this statement here. Together, they have $458. So X plus Y is equal to 458. I'm going to use the substitution method again because I already have one variable all by its lonesome self. I'm going to plug that in for X into my other equation and solve for Y. So I have Y plus 84 plus Y is equal to 458. So that's 2Y plus 84 is equal to 458. Subtract 84 from both sides, and 2Y is equal to 374. Divide both sides by 2, and Y is equal to $187. That means that Sierra has $187. Great. Let's find out what Natalie has. Remember, Natalie, she has 84 more dollars more than Sierra. So I'm going to take X is equal to Y, but Y is 187, and add 84 to that. So X is equal to $271. That means Natalie has $271. Make sure you write clearly what your variable means. So you're going to write that X is equal to Natalie, and she has $271. You're going to write Y is equal to Sierra, and she has $187. Okay, let's take a look at Alyssa and Eric. So Alyssa has $75 less than 3 times what Eric has. So right off the bat, I'm going to say that Alyssa, we're going to just call her Y. I'm going to call her Y. So Y is equal to Alyssa is equal to $75 less than 3 times what Eric has. I don't know what Eric has. I'm going to call Eric X. We just know that Alyssa has $75 less than 3 times of what Eric has. So there's my first equation. My second equation, this was my first equation in purple. My second equation in pink, together they have $905. That means x plus y is equal to 905. Once again, folks, I'm going to use substitution method. I'm going to plug in this value in for y. Here we go. X plus y, but y is 3x minus 75, is equal to 905. So all I did was plug this in for y. That's all I did. Okay? Combine like terms. 4x minus 75 is equal to 905. Subtract or add 75 to both sides. When you add 75 to both sides, you get 980 on the right-hand side. Divide both sides by 4 and x is equal to $245. That means Eric has $245. Now let's find out how much Alyssa has. We're going to take this x value, plug it into this equation for y. Here we go. Y is equal to 3 times x, but x is $245 minus 75. So I'm just bringing that down. If you want to plug it into the other equation, you can. So when you do the math, you should get y is equal to $660. I think I got this wrong. Hold on, guys. What did I do? Oh, I mislabeled it. Alyssa has $75 less than 3 times Eric, so y is equal to that. Okay. So I plug this in for y. I solve for x. So Alyssa has, I did it correctly, I'm sorry. I just had to go back and double check. $660. So make sure you are able to acknowledge your variable, give your variable a meaning. Make sure you label how much money each person has. Okay, next page, coins. Folks, just to make sure you all understand, coins. Quarters are worth 25 cents. Nickels are worth 5 cents. Okay. So Jalen has $10.35 in quarters and nickels. How many of each coin does he have if he has a total of 99 coins? Well, folks, we're going to start with variables. I'm going to use Q and N. So the number of quarters plus the number of nickels is going to equal 99 coins. There's one equation. Our second equation is going to involve the value of our quarters and nickels. So notice how the first equation I got was from here. That is just the total number of coins. The second equation I'm going to extract from my first sentence, and that is going to be based upon the value of our coins. So each quarter is worth 25 cents, plus each nickel, which is worth 5 cents, is going to equal the value of $10.35. Here are my two equations. I'm going to use substitution method to solve. Okay, so if I take this guy and solve for n, let's just say I take this guy and I solve for n. That means I subtract q from both sides. So n is equal to 99 minus q. So I solve for n. I'm going to now take 99 minus q and plug it into my other equation for n. Here we go. 0.25q plus 0.05 times 99 minus q is equal to $10.35. Now, several things you can do to go about this. You can multiply both sides of your equation by 100 to get rid of decimals, or just go with the flow. I'm going to go with the flow. Here we go. Bring down your 0.25q, and I'm going to apply the distributive property here. Make sure you apply it to both terms inside of your parentheses. So this gives me a $4.95, 0.05 times 99, minus a 0.05q. And that's all equal to $10.35. Let's go ahead and combine like terms on the left-hand side. I get 0.20q, and then I'm going to go ahead and subtract $4.95 from both sides. So when I do that, I'm left with $5.40. Now, to solve for q, simply divide both sides by 20 cents, and quarters is equal to 27. So 27 quarters, that answers part of our question of how many of each coin. How many of each coin does he have? He has 27 quarters. So if he's got 27 quarters, folks, we can take that, plug it into here, and determine how many nickels he has, or just plug it into here. So since n is equal to 99 minus the number of quarters, which is 27, the number of nickels is going to be 72. Make sure you label your solutions. So you would write Jalen has 27 quarters and 72 nickels. Okay, folks, let's talk about Isaiah. Same principle, same idea, only this time we're talking about dimes and nickels. Now keep in mind, dimes, they are 10 cents. Nickels, once again, are 5 cents. Okay, so Isaiah has a total value of $7.15. So again, we're talking about value. D for dimes plus 5 cents per nickel is equal to $7.15. This is the value, the equation that represents our value. Now the second equation is going to represent the number of coins he has. He has 91 coins. That means dimes plus nickels equals 91. Once again, just like the other problem above, we're going to use the same formula. I'm going to solve for let's go ahead and do dimes. So this time D is equal to 91 minus N. So I'm going to plug this guy into my other equation for D. So here we go. For purpose of the problem and to avoid all the dollar signs, I'm just going to write the decimal value. D, but D is 91 minus N plus 0.05 N is equal to 7.15. Once again, folks, you can go ahead and multiply 100 because all of these are in the hundreds place. You can multiply 100 throughout your equation to get rid of the decimals and work with whole numbers, but I'm not going to. We're going to get familiar and comfortable with decimals. So applying the distributive property here, I have a 9.1 minus 0.10 n, or just 0.1 n, plus 0.05 N, which is equal to 7.15. All right, so at this point, I'm going to have you guys finish up this problem. Don't forget to combine like terms. When you combine like terms, you will solve for N and get your number of nickels. Once you have your number of nickels, you can take that value, plug it into here to find out your total number of dimes. I'm going to let you finish that one up. Break even. A computer company sells laptops for $400. It costs $150 to make each laptop, and they spent $2,000 in initial startup costs. How many laptops must they make to break even? Well, folks, the initial cost of laptops for this company is the $2,000 plus $150 it takes to make each laptop. The revenue, what they get in return, is going to be what they sell the laptop for times the number of laptops that they sold. So now that you have these two equations, or rather expressions, we're going to take these two expressions and set them equal to each other. Okay. The purpose of setting them equal to each other is that it's a break-even problem. Breaking even, you want to think setting equal to. So we're going to go ahead and take 400x, set that equal to 2,000, plus 150x, and solve for x. Subtract 150 from both sides. You get 250x is equal to 2,000. Divide both sides by 250, and x is equal to 8 laptops. So in this case, we're not looking for a y value. We're just looking to see how many laptops they must make to break even. But we had to use two expressions or two equations, the cost and the revenue, to set them equal to each other. Remember, break-even problems require your expressions to be set equal to each other. So think C of x is equal to your R of x, or your R of x is equal to your C of x. So it's going to require 8 laptops to be sold in order for this company to break even. Let's talk about Brittany's lemonade stand. Brittany's lemonade stand costs $90 to build, and each cup of lemonade costs $2 in ingredients. So just like the previous problem, we're going to look at the cost. The cost is $90 to start with, plus $2 worth of ingredients per lemonade that they sell. Their revenue, so they need to earn something back. So their revenue, they're going to sell each cup for $4. She sells each cup for $4. So $4 times the number of lemonade cups that they sell. So once again, we're going to take our C of x, set it equal to our R of x, take those two values, set them equal to each other. We are trying to break even, so here we go. 4x is equal to 90 plus 2x. Subtract 2x from both sides. You get 2x is equal to 90. Divide both sides by 2, and x is equal to 45. Now remember, you are answering the question, how many cups of lemonade must she sell to break even? She must sell 45 cups of lemonade in order to break even. Okay. All right, so I'll visit you on the next video.